I think that the idea that AI is going to take all developers' jobs is predicated on fundamentally inaccurate assumptions about what it is that a developer does all day, or what they need to be able to do, or what value that they add to an organization. So it's very funny to me that a thing that can be used as a lines of code generator is like, quote unquote, the death of software engineering as we know it.
From Tuple, this is Distributed, where we show how world-class engineers and their teams tackle the challenges of remote work. I'm Jack Hanna, your host. Hey everyone. In this conversation, I chat with Chelsea Troy. Chelsea leads machine learning operations at Mozilla, where she's worked over the past 5 years primarily as a machine learning engineer. She is also a professor at the University of Chicago's Master's Computer Science program and has a wealth of experience teaching software engineers in the modern era. And that's what this conversation is all about. What are the skills necessary to learn in order to thrive as an engineer in the era of AI? We talk about what those skills are, we talk about how to acquire them and where, as well as how AI is changing the way that folks work together. Now, if you're at all concerned about how AI is changing the game in software development, this conversation is a great one for you. So Chelsea, a lot of folks are saying developers are toast, either now or close to now. You wrote a really interesting piece called What Can We Expect of LLMs as Software Engineers that suggests you probably disagree with this point, and you lay out some of the skills that you think are increasing importance in this new world order. So what are the skills that you think are most important for software engineers to master in the era of AI?
Yeah. So I think that there are 3 skill sets in particular that I see underaddressed and undervalued in like the zeitgeist about software engineering, as well as in what people train for, that we end up using all the time on the job. And I think that the advent of tools that help us with the code generation step exacerbates that mismatch rather than taking it away. So for context, when we talk about computer science education, we talk about learning to code, and we talk about coding, a lot of times the thing that we're conceptualizing is writing code from scratch, starting with a blank file and then ending up with something. And a lot of the things that we learn how to do when we're theoretically learning to code involve that step. We're learning how to generate an algorithm from scratch. We're learning to write a function from scratch. We're learning to do these things. However, professionally, what we end up doing the vast majority of the time is reading and analyzing and understanding and debugging code that either we didn't write or we wrote long enough ago that we no longer have context on this code anymore. What we end up doing most of the time is not writing code from scratch, but rather attempting to spelunk code that already exists to understand why it is the way it is in order to make the changes that we need to make. And I think what's interesting about the advent of generative tools is that they are theoretically, according to this conversation about whether they'll take away software engineers' jobs, that sort of conversation to me is predicated on this idea that they are able to replicate the skills that developers are using the most often. And a lot of times the skill that we think of as the developer skill is the writing of the code from scratch. But a lot of the understanding of the code that already exists is a thing for which we still need existing developer skill sets. And in particular, when I talk about this with students and when I talk about this with software engineers, I talk about 3 sort of categories of skill that I think are still really important for software engineers and computer scientists to focus on, that those skills will disproportionately impact their ability to excel at the field and make a difference in the field, regardless of the tools that are available and given the suite of tools that we have available now. The first set is investigative skills. I think it's still going to be really important for developers to be able to gather information from primary sources in order to understand why things are the way they are. Now, we talk about primary sources, secondary sources, tertiary sources. Primary sources are like the code itself, the tests themselves. What somebody said, theoretically, who like wrote this code could also be a primary source. As we get into blog posts and speculation and sometimes even documentation, because documentation sometimes doesn't completely follow the tool, we're looking at something more like a secondary source. And when we start talking about tools that have scoured the internet and developed summaries of what the internet says among this collection of secondary sources, what we're looking at really there is a tertiary source. And the thing is that the further and further away you get from the primary source, the more conveniently packaged the information might be, but the lower the probability that that information is accurate. And when we're dealing with a field that's as precise as computer science, sometimes the accurate answer is really, really important. We might be able to ask a large language model, for example, what might be some of the reasons that programming language designers would select a different array resizing algorithm for their programming language. But it would be much more difficult for it to completely accurately answer why Python specifically does it the way that Python specifically does. And a lot of times, the answers that we're looking for need that level of specificity. Now, Python is a language that has been open source for decades and has a copious amount of documentation as to why it is the way it is. We can expect a lot less availability of primary sources around, like, most of us, why the code base that we are working on at our employer was written the way that it was. And so those investigative skills, I think, are still going to be really, really important for software engineers. The second skill set that I think it's really important for people to continue to develop are evaluative skills. Once again, with this primary, secondary, tertiary source thing, as we get further away, as the probability gets lower that what we're looking at is in fact the complete and accurate answer, it becomes important for us to be capable of verifying effectively whether it's the accurate answer, what the accurate answer is. And so those evaluative skills, I think, still are going to be really, really meaningful for developers to have. If we look at a standard Google search and you ask a question in a Google search and the answer is not readily available online, you can usually figure that out relatively quickly by either looking at the fact that no results came back, or looking at the fact that all the results that came back are not related to the question you asked, or looking at the quality of the results that came back. It's relatively evident if the question you have isn't easily answerable online. However, if you're asking like a generative tool that sort of summarizes pieces of the internet, a question, a lot of times the answer will look as plausible as an accurate answer, even if there wasn't a lot of information to go off of online. And so we're not receiving as many leading signals as to whether or not information might be accurate. And so our ability to evaluate it, I think, has become especially important. The last skill set that I think it's really important for software engineers to focus on are innovation skills, because what our current technology is able to do is provide faster and faster and more convenient indices on the knowledge that is already readily available. And in particular, with the latest tools, usually we're talking about readily available online. And though that information that's readily available online gives us less insight into what's next. A lot of times to innovate, we need to run our own experiments, generate our own knowledge, be able to synthesize concepts from disparate fields. One of the things that I find really interesting to learn about right now is things like history of microbiology, history of medicine, these sorts of things, because in reading these stories, one of the most fascinating things for me to learn about is how we figured out the things that we know. And a lot of times the ways that we have done that involve a lot more creativity and chance and just sort of general luck even than I think we necessarily give them credit for. And I think the same is true in computer science. I think that to the extent that we want to be able to advance the field and come up with solutions that have a better trade-off profile than the solutions we currently have, or even solve problems that we haven't solved yet, those answers are not going to be available in an index. And so it's still a thing we need to be able to do.
Yeah, that's fascinating. I'm curious how you arrived at these three skills as particularly important, because when you say it, it makes a ton of sense, but I'm wondering if there's an example from your own experience that sort of led you to realize these three skills are of particular importance now.
Sure. Yeah. I would say that some of it has to do with my initial experiments working with large language model tools. And a lot of it also has to do with working with my students. I teach master's students in computer science, and for a number of reasons for them, it's making a lot of sense for them to try to use generative AI tooling while they're trying to do their homework and learn things and figure out what is going to be effective, and then go into a job market where the thing that sort of the zeitgeist is convincing them of is that either they're going to be replaced by these tools or they need to be able to use these tools in order to not be replaced. And so as a result, I've developed sort of this compendium of experiences with both using the tools myself as well as coaching other people who are using the tools. And it's interesting to see what outcomes folks get and when those outcomes support their goals and when those outcomes seem to be kind of detrimental to their goals. So I think the most interesting example that this is the sort of most interesting unitary example that I can share is that I was taking a workshop in February that was about building interpreters. Over the course of the week, you would build an interpreter from scratch in this toy programming language called Locks. It was designed by this person, Bob Nishram, for the purpose of teaching interpreters in a book that he had written. And so this was a workshop that was based on the first half of that book, in which you build a compiler in Java for this programming language called Locks. Now, the difference in this workshop was that we were doing it in Rust instead of in Java. And the idea wasn't really, it was to learn about compilers, but a secondary important characteristic of this workshop was that it would give us an opportunity to learn about a lot of the important features of Rust that make Rust a programming language that people would want to use for something like this. And Rust was not a programming language that I had written a lot of before. This felt like a good opportunity for me to experience what it is like for my students when they come into my class. I teach Python classes. And so for me, attempting to solve programming problems in Python using one of these tools doesn't mimic my students' experience, because unlike my students, I've written Python for a very long time and have figured out how to teach it to them. And so it's much more familiar to me, which means that I'm going to have a much easier time evaluating when generated Python is incorrect than I would with something like Rust or something like that. Now, the way that these tools are trained makes them pretty good at generating accurate code, because there are very firm, clear patterns as to which tokens follow which in programming languages. Much clearer and much more deterministic, really, than natural language. And the vocabulary is also very, very small relative to a natural language. So it doesn't take as many examples of a programming language for these things to generate accurate code. And the Rust, a lot of times that it was able to generate, was mostly right. It was mostly right. I would say that in the course of building this compiler, with my commitment to attempting to use a generative AI tool as much as possible to do it, the amount of actual typing of code that I had to do relative to when I would build one manually, I think was reduced by about 95%.
Sure.
In order to get the compiler working properly, which meant finding those areas where the information was incorrect and then fixing it, I think the amount of knowledge that I needed to have, both about Rust and about compilers, was reduced in my use of the tool by about 5% in order to get it working exactly the way that I wanted it working. Now, could I have gotten sort of an approximation of a compiler that more or less did things with less knowledge than that? I think I probably could have. But what I found was that the amount of information that I needed to have personally in order to be able to get things working the way that I wanted them working wasn't reduced by all that much, which meant that I still needed the ability to gather that information. And a lot of times it was weird edge case stuff, or it was I need to understand actually what's happening with the ownership of these objects in Rust rather than just the syntax. This is a thing that I need to understand about the way that Rust is implemented. And in order to gather that knowledge, what I ended up needing to do was investigate to figure out what the accurate answer might be, evaluate that against what I was looking at. And then, with something like a compiler for a teaching language that's specifically designed for people to learn how to write compilers, I did not find myself doing that much innovating. However, the answers that were the most helpful to me out of tertiary source material were, these are the different reasons that different compiler designers have chosen different ways to do this in the past, which is helpful for building the contextual background necessary to get to the next step of what the future might look like, but doesn't actually take that step. So far, it seems to me that in my experience, and in my students' experience, my students have still needed to take a lot of those steps themselves. Does that answer the question?
Yeah, no, I think it does. And it surely behooves them to take that step, because that gives them the feedback loop, right? It gives them the ability to say hey, was my judgment, was my evaluation in this case good or bad, right? Because they had to take that action versus just watching somebody else do it. What advice would you offer to folks who are looking to level up in these three areas?
Ooh, that's a good question, because a lot of our education focuses on writing code from scratch as well.
Right.
But when it comes to building these things, I found that there are a couple of tools that are really, really useful. An exercise that I assign to students and also recommend to people as they're trying to level up on their investigation and evaluation skills is finding an open source code base that's really well documented with regard to how decisions were made in it. Now, these are pretty hard to find, but as it so happens, the Python interpreter is one. You can go on GitHub and you can see the code of CPython. It's in C, and so for folks who haven't seen a lot of C, it's necessary to look at some C, probably. But it is a really useful exercise to try to figure out how something has been implemented in Python. And that is helpful with the investigative part. And that can be looking at commit messages to understand how something was done. It can be looking at the code itself. It can be looking at the tests. From there, I think that the next step in this exercise is useful for developing evaluative skills, which is understanding why it was done in the way that it was done and examining the trade-offs associated with the choice that was made, comparing that to the choices that other programming languages have made, for example, the implementation of Java, the implementation of Ruby, et cetera, and compare how those choices differ and the different trade-off profiles associated with those different choices. Now, this, I think, sometimes feels like a deep exercise to people. And I think the reason it feels like a deep exercise to people is that the code that we're using for it is compiler code rather than end user application code, which is mostly what people look at all day. But I think the counter argument I would make to that is that code is code, and an end user application written in C would have the same loops and structs, and it would be the same syntax as what a programming language is. The difference is that an end user application is taking input from a customer and doing something with it and then outputting something that the customer wants. A programming language is taking in source code, parsing that source code, implementing something on a machine, and then giving the result back to the person. So the belly might contain different internals, but the shape of the animal is not so different from that, the one that folks will be familiar with from having worked chiefly on, or even exclusively, in end user application design. Now, when it comes to innovation skills, that's a harder one to develop. And I think the place that I recommend students begin is with transferring insights from one field to another field. It can be difficult to come up with insights sort of like independently from whole cloth, particularly in a field that you've been studying for, by the time students come to me, we're talking about somewhere between 1.5 and 3 years max, usually. And so, but what they can often do is, a lot of my students are coming from other careers. They came from a biotechnology career. They were an art teacher, like whatever the situation was. And what's really cool about that is that it then gives them a completely different frame of reference from which to view computer science. And the more that I learn about the way that humans have developed new knowledge over the course of time, the more evident it is to me that a vast proportion of scientific and technical advancement comes from somebody who was a runner, who knows how it works in distance running or whatever, now comes into this field and tries some of those insights on this field. The degree to which insight transference can lead to innovation is really fascinating and really inspiring. And I think a great place to start for people who are trying to work on that skill and have a couple frames of reference to use.
Yeah, that's really good advice. To repeat some of that back, it's basically like where you would start, particularly for your investigative and evaluative skills. Find some open source projects with great documentation on why things were implemented the way that they were implemented, and read that and examine how that differs on different projects, different languages, what have you. And sure, while that may be different than what you might see in a consumer application, a lot of the core ideals or principles behind those decisions will probably carry through. And I think there's an added benefit of just also learning how some of these great open source projects work may just teach you something very practically that you will use directly in the next consumer application that you, that you build. And then on the innovative side, it's sort of like maybe there's not a playbook for exactly how to learn the skill as much as it is an encouragement to try things you've seen work in other places and do the scientific process, try stuff, see what works and iterate. I guess I'm sort of inferring there, but that seems to be the vibe of what you're suggesting.
Yeah, absolutely. That's 100% the vibe. It's a thing that I really encourage students to do in their final projects. And side benefit that I have noticed from this is that it tends to be a pretty motivating exercise for students too. There's something really fun and interesting about being able to position yourself as an expert in one area and a beginner in another area, and figure out whether your expertise in one area can help you learn something or contribute something to this field where you're a beginner. And I've seen some really cool projects. I had somebody one time for their final project to make a board book, like a children's board book that explains sorting algorithms with frogs. Like frogs on lily pads. And it was just really, really cool. And I think they tried it with some of their nieces and nephews and stuff like that. And they aren't like going for publication or anything like that. But even looking at it, I thought to myself, like, man, when I was learning sorting stuff, that I wasn't 7 and I still would have really appreciated this board book.
Yeah, that's awesome. One thing that I noticed was notably missing from the list of skills that you mentioned was collaborative skills. You mentioned that like a disproportionate amount of the stuff that we learn in a degree program or when learning code is how to write code from scratch. And compared to in practice, such a high proportion of the time we're spending looking, debugging, adding to code that was written by somebody else or ourselves so long ago that we don't remember the context. It seems to me that a huge amount of that time is also spent interacting with other people, owning the code as a team, understanding the code not just from reading the code itself, but from talking to the people who wrote it in the first place. And so what I didn't hear you say was collaborative skills, technical persuasion skills, any of this other stuff that is involved in the job of software development that isn't explicitly writing code. Is there a reason for that?
I think the reason for that, so first I'll say that collaborative skills I find are probably the most important skill that I find myself using on a day-to-day basis as a software engineer to get anything done. I think the reason that I exclude them from those 3 skill sets is that the need for them doesn't feel like it has been exacerbated by the advent of generative AI tools. They were, I think, that collaborative skills are a thing that are extremely valuable and undervalued in tech, about the same amount now as like sort of before the advent of ChatGPT, but they remain a really important thing. And a thing that I talk to students about actually pretty frequently is that they will find their collaborative skills to be the limiting factor in advancing as a technologist beyond a certain level. I think that there is some level before that where technical acumen could be the issue. But as you're getting into like senior, staff, principal, at that point, you are no longer usually responsible for implementing things. At that point, you're usually much more often responsible for creating the nice terrarium with the problem in it and the information in it so that one of those mid-level engineers or senior engineers then gets to go in and solve the problem. And the creation of the terrariums very frequently involves talking to a bunch of different stakeholders and understanding what needs to happen, or seeing sort of down the road as to what the business is going to need and being able to figure out what technical requirements are going to need to be fulfilled in order for that to happen. Or it's even looking at your reports, if you're an engineering manager, looking at your reports and understanding that in order for each of them to get a good performance review, they need to be able to demonstrate having worked on an impactful project, which means to the extent that you will succeed at getting them those positive performance reviews, you need to be on the lookout for these impactful projects, and you need to be keeping a keen eye on whether the projects that they are on are remaining impactful. Move them, if they're not going to be impactful anymore, onto impactful projects. And a lot of that is talking to people. A lot of it is understanding what's going on in the organization in a way that I think staying in an individual silo doesn't necessarily support. I do think engineers can get away with it relatively early in their career. But I think it's a thing that we very quickly stop being able to get away with. And it's a thing that I was very lucky to spend the early portion of my career practicing, because early on in my career, I worked at this place called Pivotal Labs. It's 100% pair programming there. And so all of the time, almost all of the time, occasionally the team is odd for a day or whatever, but almost all of the time you are working with somebody else 100% of the time on the programming problems. And you get the opportunity to practice collaboration on the small stuff in a way that provides excellent practice for collaboration later on the big stuff. And it doesn't end up being such a massive skill shift from engineering into like engineering leadership or tech lead or any of those things.
Would you say then that pair programming is particularly useful for folks earlier in their career because it gives them the chance to develop those skills before they're necessary?
I think so. I was very grateful to have had the opportunity to do so much pair programming so early in my career, which is not to say that I think it made things easier. I think the thing that I learned when I went from writing a lot of code independently during my training to doing 100% pair programming was that I needed a lot more. There's like this social stamina piece, which is not, which doesn't develop entirely differently than the way that physical stamina does. If you start a new sport or you start a new physical discipline, you find that you're very hungry, you're very tired, and it feels really hard in the beginning. And that's the way that pair programming felt to me. If I wasn't at work or I wasn't studying, I was basically sleeping for like my first 4 months at Pivotal Labs, I would say. And a lot of that was just talking to somebody all day, every day was a lot. It was a lot to get used to. Eventually I was able to get used to it, and I still really enjoy pair programming. I 100% understand why folks who don't do it that often sometimes alight on this opinion that they've tried it and it's hard and they don't like it, because the amount of time that it takes to build up the stamina necessary for it to feel like you're reaping the full benefits of it, in my experience, was like about 4 months of doing it full time. And usually when people say they tried it and they didn't like it, what they mean is like, I've tried it for a sum total of 8 hours, which feels sufficient to say that I'm not into this. And like, I think the thing that I would challenge people with is that like, if you start weightlifting, okay, and after eight sessions of weightlifting, it still feels hard. You don't have enough information yet to determine, and you're like, I did it for 8 sessions. I don't have muscles yet. I'm not strong yet. I'm mostly tired and hungry and sore, and this sucks. Like, I get it. And also, you like have to keep doing it because it's a skill. It's a skill set that you have to develop before the benefits are going to feel like they're entirely there. And I think we've probably done pair programming a disservice by characterizing it as this thing that people are going to experience immediate benefit from. Because although I think that that can be true in certain circumstances, I think the energy outlay for folks who are not used to it is large enough that it would benefit from being characterized the same way we characterize other skills, which is like, this is going to be difficult at first. And there's the benefits will feel worth it when you get there, but it won't necessarily always feel immediate.
Yeah, I really like the weightlifting analogy because it feels so obvious. It's like nobody would go to the gym, or almost nobody would go to the gym eight times and just be like, why am I not super strong yet?
Right.
But you can find plenty of people online who've pair programmed once, twice, certainly fewer than 8 times, and express similar frustrations and kind of written off the whole practice. I like that a lot. So what's interesting though, I have heard a lot of people describe working with LLMs as, like an AI pair programmer. It's like having a pair programmer with you 24/7. Do you think the advent of Gen AI tools is fundamentally changing the way that folks collaborate together or need to work with other people?
It's a good question. I think there are a couple of fundamental differences pairing theoretically with like an LLM versus with a human. I think a lot of times with pair programming, the thing that people are nervous about is being judged. They're like, oh God, my colleague is going to figure out I actually don't code that fast, because I don't know, people have seen hacker movies or whatever, and they think that other people code like that. Nobody codes like that. Nobody does that. Or people are like, oh, I'm going to make so many typos, or like, what if I have to look up a piece of syntax and like my colleague figures out I'm a hack? I think that the ubiquity of the imposter syndrome trope in software engineering in particular, I think a lot of people in software engineering feel like they shouldn't be here because they don't know all the things. And I think a thing that exacerbates that is the fact that software engineering is like 80% doing things we've never done before. Because if we'd done them exactly this way before, we wouldn't be getting paid to do them. People would be buying the much cheaper off-the-shelf tool that already does it. And then with people who already feel that way are now told they're going to be coding in front of other people. Like, oh no, I'm going to be found out and I'm going to get fired. Whereas with the LLM tools, I think there's less of that because people aren't worried about getting judged by their tooling. And so they're perfectly happy to go to the tool and be like, not only honest about what they don't know, but even like indignant about the fact that the information isn't more obvious. I think the availability of large language model tools and their utility for answering the questions that we ask has this sort of ubiquitous appeal because the indices that we're comparing it to are a lot of times like a Google search that's going to give us 3 general answers, but not before we click through 5 different ads. Or like a Stack Overflow post where somebody asked how to do X, and the first 5 answers are like, why do you want to do X? Don't do X. Like, I think that the fact that we have like lapped up this tertiary source that is sometimes incorrect. Like, I think it's fair to have some shade for it, but I think it's also fair to point at the alternatives and be like, okay, was this better? Was the other thing, like, from a purely pragmatic speed of getting to the correct answer perspective, I think that there is a valid case to be made for a competitor in that area. And I think that it can be, to the extent that we were previously using like a literal rubber duck as a pair in an effective way to be able to get ourselves the answers, because just even talking through it with ourselves was providing us with utility. Being able to talk it through with a tool that's like not always right, but has a lot of context from the internet can yield really promising results and can be really useful for people. Now, do I think that it would like replace pair programming? I kind of don't, because I think a lot of the investigation and evaluation and innovation pieces of programming are pieces that benefit enormously from pairing. The places where it was really valuable to have someone beside me was where we couldn't figure out what was going on. And I think even in a world with large language model tooling, there are going to be cases where we need to do some investigating to figure out what's going on. Or cases where we've got all these answers, but we're not really sure which one is right. And it's helpful to have a thought partner to figure out how to evaluate which of these things we ultimately want to go with. Or have somebody else's experience, a thing that we didn't even think about asking about of a tool, to be able to transfer ideas from that other experience onto this problem and try to come up with a solution. So I think it is changing the way we work. I think it provides us with a tool that can be really, really useful for getting to an answer, and can in particular be a boon for folks who are used to working alone, who are now able to reap some of the benefits that were previously provided exclusively by things like pairing that can now be provided by a tool like this. Do I think that pairing still has a place? Absolutely, I do.
Yeah. Well, what I heard you say, I guess, is that collaborative communication, technical persuasion skill set is probably the number one skill set for a software engineer to develop in order to advance deeply into their career. The need for that is mostly unchanged with the advent of generative AI, which is to say it was always very important and continues to be very important, if not the most important thing in your mind. In the advent of AI, investigative, evaluative, and innovative skills become more important. Those also get amplified by things like pairing. And so probably in folks' best interest, particularly earlier in their career, or if they're looking to make that jump from senior staff, principal engineer to buckle up, try some pairing, or work specifically on developing those communication collaboration skills. And so that's pretty interesting. Or to shift gears a little bit, I happen to know that you think it's still worth studying computer science in a formal capacity. It doesn't totally feel like to me most of the skills that we've talked about today are commonly taught in formal CS degree programs at university or otherwise. I've read some of the work that you're doing at the University of Chicago to kind of rethink your curriculum, and I have no doubt that you're addressing these things. I suspect most people are not, though. The level of thoughtfulness that you apply and the time, clearly, that you apply to getting this right is incredibly impressive. Maybe we'll get to that in a little bit. But why do you think it's still worth studying CS in a formal capacity when, at least to me, the skills you've listed to be most important aren't the skills most commonly taught in these types of degree programs?
Yeah, this is a great question. I think I would make a distinction here, which is that I do think it is still valuable to study CS. This is a question that a lot of my students are coming to me with, which is like, is there a point in me being in this degree program? Like, why I'm spending all this money and I'm being told by like whatever, the Mark Zuckerberg press or whatever, that there's not going to be a job for me by the time I graduate. What is the point in me doing this? And I think for those students, the thing that I would say to those students is that if you are already enrolled in a degree program for computer science, I think for most students who come to me with this question, my speculation is that it is worth it to stick it out. And I think that that is true in the particular context of the time that we are living in. But I'll get back to that in just a second, because I suspect that there are a lot of listeners also who are not currently enrolled in a computer science master's degree program. I do think it is still valuable to study computer science. I am relatively indifferent to whether people do it in a formal capacity or not. One of the things that is interesting, one of the questions that I still find challenging to answer from my computer science students is what classes they should take in their master's program, because it is the awkward question where I need to address with them directly that I'm speculating, because I do not have a master's degree in computer science or a bachelor's degree in computer science. I did not study computer science at the postgraduate level. I studied international relations as an undergraduate, and then I was in that field for a while. And then I moved over into software engineering by what we would often refer to as a non-traditional path, kind of, and started in software engineering, and then ultimately went back and got a bunch of like the algorithmic and data structures knowledge and stuff like that. But even that I did by like reading books, taking workshops. I didn't go back to a formal degree program in order to be able to do that. I think that the thing a formal degree program does for you is it helps to like organize the classes for you in a way that's like effective enough, and then you don't have to do the executive function of like putting all that stuff in order for yourself. And so for someone who's like, look, I really just need somebody to lay it out for me, like, then that would be the way to go. If somebody who's totally into laying it out for themselves and doesn't mind the like independent study thing wants to do it outside of a degree program, more power to them. It totally works. That's what I did. But I think that a lot of times the question that at least students are coming to me with is like, is computer science a thing that is a field that is worth studying, period? Like, they're asking less about the formal part and they're asking more about the like, what am I doing here? And I think the thing that is useful about studying it is that the context of understanding how other people have solved problems, whether those are algorithmic problems or structural problems. Basically, we got the transistor, and from then on, computer science has been different people inserting their opinions about how to do more stuff in less space in less time. That's been the question. Transistor, how do we get more stuff in less space in less time? And most of the things that we've done are answers to that question, or proposals as to how to answer that question. And I think that gathering experience with the proposals that other people have made is really, really useful for being able to make your own. I think that's the first reason that it is useful to study. I think the second reason that it is useful to study is that a lot of our modern zeitgeist about the way that the field of computer science and software engineering has developed is like inaccurate, honestly. Like, I think a lot of for example, this like, I think that the idea that AI is going to take all developers' jobs is predicated on fundamentally inaccurate assumptions about what it is that a developer does all day, or what they need to be able to do, or what value that they add to an organization. Because I would argue that we have known that the number of lines of code that you generate is divorced from your impact on or value to the organization for a very long time. So it's very funny to me that a thing that can be used as a lines of code generator is like, quote unquote, the death of software engineering as we know it and stuff like that. And I think we have a lot of these sort of like programmer myths that we've repeated one to the other that are predicated on inaccurate reads of what the history of computer science is. I think another one is this idea that like tech is apolitical, that tech is not political, that tech doesn't have to be political. I've been studying the history of computer science for a long time, and I can't find an apolitical thing about it. There isn't a single thing about the history of Alan Turing's work or life that wasn't political. There isn't a single thing about the history of Ada Lovelace's work or life that wasn't political. There isn't a single thing about the history of the growth of Microsoft as a company or the reasons that Microsoft was founded that's apolitical. And I think that attempting to divorce computer science from that context is another way that we impoverish our ability to have the impact that we want to have in this field. And I think that studying that piece of it is not only extremely valuable for us as modern practitioners of the field, but is also the thing that has saved me from like the feeling of ennui and boredom and burnout and hopelessness that I think is really easy to run into if you work in this field for too long without that background. And I think part of it is just, if you work too hard for too long, you get burnt out. That's part of it. But I think there's this separate thing that happens in software engineering of like, what is even the point? And I see students come in with it and I feel bad because I'm like, man, y'all have been in this field for like, you haven't even really been in it. You've been exposed to this field for a year and a half and you're already like, what is the point? And I want to like, there's a lecture that makes no sense in any of my classes, so I can't give it right now, but I really want to give it at some point. That's like the 7 life lessons that we can learn from studying the work and life of Alan Turing. And like, no one's going to argue that this person wasn't instrumental to computer science. This isn't just somebody who won a CS award. This is the person the CS award is named after. And, I think that the stories of some of these people and the problems they solve, why they solve them, how they solve them makes me inspired and proud to be in this field at a time when like a snapshot of the field the way it is currently doesn't make me feel that way. But in order for us to get out of this snapshot, I think people do need to feel that way. And I think the opportunity for them to feel that way is there in the study of the giants whose shoulders we stand on. Does that make sense?
I think so. I mean, to summarize it really almost tritely would be, yes, still worth studying it. How you study it maybe matters a lot less than the fact that understanding the history, the path that got us from there to here is a really useful like tactical resource for doing our job day to day as practitioners, but also resource to work through the malaise, the self-doubt, the burnout that can arise from working in a field too long and give us hope for what is to come.
Right. I find it to be a very valuable, to use your terminology, it's a good tactical resource. And it's also been such an important kind of emotional resource for me, like I don't know, psychological capacity resource kind of.
Yeah, I dig that. I have a series of rapid fire wrap up questions that I want to get to and make sure that we have time for. You ready to go through a couple of rapid style questions that aren't meant to go super deep on, but get sort of a short take from you on to leave the audience with something before we drop?
Yeah, absolutely.
Does that work for you?
Yeah, let's do it.
What's the best piece of advice that you'd offer to somebody just starting their career in software?
Oh my gosh. Just starting their career in software. The thing that I would say is learn to read and investigate other people's code.
That investigative skill. Yeah. Okay, cool. What's your favorite tool, physical, digital, or otherwise, that you're using these days to improve your own productivity or happiness?
I have, oh, you're going to hate this answer. I have like a college ruled notebook that I write things down in. And there's something so helpful about checking stuff off. And I like being able to draw pictures in it and stuff. I don't know. It really helps me.
Yeah, I don't hate that answer. I have a moleskin right next to me that I use all day.
Nice.
So I dig it. What's one question about remote work you don't yet have the answer to?
Oh gosh, how to collaborate effectively across time zones. When you get to like 8 hours, 9 hours, 10 hours, I have not found a good. I mean, you can try asynchronously, but I don't know. There's a piece of like the joy of synchronous. There's the joy of getting to know people that's like harder to do across time zones, at least for me, at least in programming. And I would love to find an answer to that.
Yeah, I'm not sure that there is one. I think, I suspect it's spending sufficient time in person to make up for the fact that you don't get as often remotely is my guess. But who's a technologist or just a tech person generally who you've been paying more attention to lately or really admire?
Yeah. Right now, I'm going through a lot of the Stack Overflow answers that were written by Tim Peters, one of the people who implemented a lot of the early pieces of Python, because he was particularly at the time very instrumental to the implementation, but also extremely open online as to why things were the way they were, and would like just go answer random people's questions on Stack Overflow. And so I have found his answers to be a really useful source of information for the purpose of motivating and clarifying the lessons that I'm writing for students for the fall.
I dig it. Well, it also sounds like he is a core resource who's allowing us to develop our investigative and evaluative skills and finding open source projects with good documentation about this stuff. So kudos to Tim Peters, and we'll link to his bio or some of his work. That's awesome. Well, I guess before we formally close, Chelsea, are there any other messages or thoughts that you've had as we've talked through this stuff that you'd like to share with the audience before we wrap up?
So I will say, I mentioned that I think an important thing for people to do when they are starting out in programming is learn those investigative skills. I have a tutorial video that I give to my students about like a step-by-step way to look at code that I can give you the link to for the show notes. So I'll do that. It might be on my Thinkific, but I'll just make it like, I'll make it public access.
Awesome.
But,
yeah, that'd be great.
So anyway, if folks are interested in a place to start, that might be one.
That's awesome. I'm sure folks will appreciate it. So thank you. And if folks want to find you or your work online, where should they go?
Oh yeah, I have a blog. I have been keeping that blog since 2014, so it's like old enough to ride a bike and stuff now, which is terrifying. It's at chelseatroy.com. It's Chelsea like the neighborhood in New York, Troy like Helen of Troy, and then .com.
Good deal. Well, we'll link to that as well. Chelsea, it's been a pleasure. Thanks so much for being generous with your time and perspective.
Of course, my pleasure. Thanks for having me.
Thanks for joining us on Distributed. If you want to learn more about what we covered in this episode, or if you want to share your own thoughts, follow @Tuple on X or visit distributed.fm.